with cost optimization and their solution. But first, I want to set a foundation, right? I want to build a base that we can operate from. And to start with that, I really want to start from the position of value, right? Because it's not just about money, right? I could tell you, oh, well, don't spend any money, right? And that would certainly allow you to save it, but it's probably not going to allow you to make it. It's probably not going to be good for your business, right? What we really want is we want to get the maximum dollar from the money that you're spending, right? Focus on being efficient. Focus on being effective. And you've probably heard the phrase penny wise and pound foolish, right? We want to avoid that. What you really want, ideally, is you want to build a process of ensuring value across your infrastructure. Maximize the value that you're providing to your end user, right? So let's start with an example, a customer example. Infor is one of our all-in partners, and they're saving $90,000 a month. That's a pretty big number. And you're probably asking, well, hey, how'd they do this, right? The way they do this is all of their development environments are shut down at the end of the day. It's pretty simple, right? If you're a developer, you can apply a tag to your environment or to your instance and say, you know, don't shut my instance down. But for the majority of people that are doing development, they're going home at the end of the day. That instance could just be sitting there, it's not doing anything. So they shut that down. After a period of time, let's say a week, if that instance hasn't been restarted, it's terminated, it's deleted, right? And so they've built this process. It's an automated process. No human has to intervene in it. They built this process to remove these environments or remove these costs, right? And this is a common tactic that you can use. It's not complex. It can save you a significant amount of money with a little bit of investment. Okay, so you're probably thinking, hey, Elvis, this sounds cool. How do I get started, right? I want to maximize value. What's my first step? Well, do you know where you're spending your money today, right? So the first thing you have to do is you got to monitor, right? You got to measure, right? Measure all the things. And once we're measuring, we can start to look for the low-hanging fruit that we can optimize. Look for things like Infor was doing. Look for those unused resources, right? It's simple. Turn it off, delete it, right? Look for underused resources and resize them, right? Or right-size those instances. Keep an eye out for new design patterns, right? Migrate to new services, use containers potentially, use auto-scaling, and then do forecasting. So it's not just monitoring what you have today, it's looking into the future to say, well, what are my future needs going to be? And what that does is it allows you to align your purchasing with your usage. And it allows you to be proactive instead of being reactive. Okay, that all sounds pretty good. What kind of tools do we have to enable us to do this? Well, AWS offers a number of built-in tools that you can use. And I've listed a bunch of them here. We're going to go and we're going to talk about each one of these in detail, some more than others. And then we're also going to take a look at some third-party products that you can use. Okay, so the first thing I wanted to talk about is CloudWatch. So CloudWatch can help you monitor your costs by sending you email alerts when charges exceed a threshold that you define. And the way that you do this is you enable detailed billing reports in the AWS Management Console. So in the Management Console, in the Billing and Cost Management section, you just check that box, and that's going to enable those billing reports or alerts, and you can set the thresholds that you want in CloudWatch. You can also define custom reports that get sent to you. So here we have a cost allocation report and a detailed billing report that have been selected. The other thing I want to highlight here is that This cost data is something that you can easily upload into Amazon Redshift and Amazon QuickSight. So this will allow you to visually analyze your AWS cost and usage. You can also enable consolidated billing. So if you have multiple AWS accounts, you can roll all that up under a consolidated billing account and create one bill. And you can view that whole bill under this, or you can break that down by those individual accounts. Another tool that we provide is Trusted Advisor. And Trusted Advisor does a bunch of recommendations and optimizations, right? Security and performance and things like that. Today, I'm just going to talk about cost, but it's really good for all of these things. This, once again, is built into the management console. And what will it do for you? Well, it'll do some of those low-hanging fruit things that we were just talking about. So looking for underused or unused resources, EC2 instances, idle load balancers, idle Amazon RDS instances, unassociated elastic IP addresses. It's probably not a big cost, but it'll tell you about them. It'll also tell you about underutilized EBS volumes, right? So you can rack up a lot of costs with EBS. It's a nice way to see what you can optimize. And last, but certainly not least, is a tool called Cost Explorer. So Cost Explorer keeps up to 13 months of historical data that you can report on. It also forecasts up to 3 months forward based on that historical data. The data in these usage reports or Cost Explorer reports is updated multiple times a day. And the whole idea behind Cost Explorer is to make it really easy to visualize what's happening with your cost. Okay, it's got a bunch of predefined views that you can execute to see what's happening with your infrastructure. You can also create custom reports and filter those based on your needs. In addition to Cost Explorer, we have a feature or a service called AWS Budgets. So you can set your own budget. And it uses the visualization from Cost Explorer so you can visualize your budget and see if you're meeting your budget, or even it will project out using that forecast if you're going to project over your budget, and you can configure that to send you an alert as well. So a bunch of tools that AWS provides for you. In addition to the tools that we provide, we have a bunch of partner solutions. So we have Cloud Health, Cloudability, Cloud Checker, Cloud Splunk, no, just Splunk. Splunk and Cloudamize, right? It seems like everybody's cloud something. But, let's take a look at a couple of these in a little more detail. So, I just picked out some features here that I think are interesting from the perspective of each one of these partners. So the unique features I see here with Cloud Health are right sizing, right? So that's EC2 capacity resizing, that's EBS and storage optimizations. Reserved instance optimization, so when, where, and how to leverage reserved instances across EC2 and RDS. And they've got this really cool feature, I just titled it respective tagging, they call it dimensions, where if you're using tagging but those tags haven't been applied correctly to the resource initially, you can go back and you can tag them retrospectively so that you can build an accurate cost analysis. That's pretty cool and pretty handy. They also have an API, so you can build your own automation around it. And one of the other features I really like here is their integration with Datadog. So Datadog is another third-party monitoring tool. And this is a screenshot of that interface. And really the reason that this is interesting is because if you can provide visibility into cost, then that visibility will hopefully bring responsibility along with it, right? It's going to imply responsibility, because if somebody says, oh, hey, so-and-so spent so much last month, right? Or even if I could see how much I was spending, that's going to help kind of keep me in check and say, oh, wow, that's way out of line, or man, I'm really have optimized my costs. So the visibility begets responsibility. I like that. One of the other partners I wanted to talk about was cloudability. And we see a lot of the same features here, right? Right sizing, storage and database optimizations. One of the things that they do is really cool is here, I don't know, you can't really see that pointer, but they have this thing called the impact score, right? Because you could certainly optimize things like your unassociated or unallocated EIPs, but I wouldn't prioritize that because it's not a lot of money, right? This gives you a very visual way to see which things you should prioritize, because that's going to have the maximum impact on your cost. They also do RI recommendations, both standard and convertible recommendations and modifications. And once again, this is a way to figure out what to buy based on your compute and use case. And ideally, continually modify your purchases to fit the changes in your environment. If you have an environment that's continually changing, right, you're doing software-defined infrastructure, your costs need to be continually monitored as well, right? They have an API, so you can automatically or create your own automation around that. And if you want to know more, they're giving their own talk, ENT 202, driving cost efficiency. So that might be worth checking out. Oh, and the other thing, all those partners that I listed before, they have booths here. So if you want to know more about them, just stop by. Okay, so we're warming up, right? We've learned a few things. We're monitoring. We saw that we can gain great efficiencies by doing things like killing zombies, right? Killing those dead instances or underused resources, just like Infor did at the beginning. One of the things I want to call out, though, is avoiding complexity, right? Focusing on the things that you can do to simplify your environment. So a great example of that is regions, right? We've got 14 regions around the globe now, and more coming online soon. Sometimes people will do things like, maybe they're a startup in San Francisco and they want to deploy, and they've deployed to US West 1, right, which is our San Francisco region. Well, there's different regions cost different amounts. So is that the appropriate thing to do for their customer, right? Where are their customers based, right? Because if they could serve that customer out of a different region, they could potentially lower their costs, right? What's the latency impact for their customer? And what about your backup strategy, right? It's great that we have multiple regions, but do you need a fully redundant, highly available copy of your infrastructure in multiple regions? Maybe you do, but if you don't, maybe you can use a pilot light architecture where you just have your data there and then you can spin up the infrastructure as needed. So the other thing I wanted to highlight here is that we have a number of instance families and lots of instances in those families. And one of the things that's important is to understand your application and the instances that are going to be most appropriate for your specific application. How do you do that? Well, you benchmark your application, right? It's pretty inexpensive to spin up an instance, run some stuff, and shut it down. So do that. Understand your application. Understand, is your application CPU bound? Is it IO bound? Does it have memory constraints? What are the parameters? And that allows you to do that right sizing and get the exact instance or set of instances that'll work for you. In addition to instance types, AWS offers numerous storage options, right? Leverage the right one for your specific workload. A couple of ones I called out here, S3 infrequent access, right? Which does exactly what its name implies. Amazon Glacier, or long-term archival storage. You can do things like use S3 lifecycle policies to automatically move your object from one storage class to another. Automatically archive objects that have aged to a certain point. Or even delete them, right? Even better, if you don't need them. And an example of this, I'm going to go back to, hang on. The other thing that we offer, in addition to these types of storage, is we offer different EBS volume types. So we offer magnetic, GP2, ST1, SC1, provisioned IOPS, lots of different options there. Which one's right for you? As an example, Infor, who I talked about earlier, they changed their backup strategy to use the Amazon EBS ST1, which is a throughput optimized version of EPS, volume type, specifically for their database backups. And in doing so, they saved 75% of their monthly backup cost just by changing the type of storage that they're using, right? And as a side bonus, they got better performance too. So if you want to know more about that, we have a case study on our website about it. But that's just a cool example of a simple change that saved a lot of money and actually gave them better performance. So in addition to instances and storage, we also offer a bunch of managed services and application services. And using these can simplify your environment and potentially lower your costs. So what about an example of this, right? So if we combine these things that we've been talking about, we can take a look at a environment and do an optimization. So we take a standard environment here. We've got 4 medium instances in different geographies around the world to serve our customer base. And it's costing us about $300 a month for those instances and a terabyte of transfer out. If we re-architect this environment so that we're using a single instance and we're using CloudFront and those different locations, we can cut our cost in half while improving the performance, right? Just one simple example about how you can optimize your architecture. And we're going to take a deeper look at CloudFront in a minute, but I just wanted to throw that out there. So we talked about a number of things. Let's talk about the options that you have for purchasing EC2 instances. So we've got on-demand, pay-as-you-go. We've got reserved instances, so you commit and you get a lower price. And then we have spot instances. And I want to focus on spot here because of all of these, spot is one of the ways that you can save the most money. So with spot, the rules are simple, right? The market is where the price of the compute fluctuates based on supply and demand. And the second rule here is you never pay more than your bid, right? So it's essentially an auction. In fact, you'll only ever pay the marketplace. You pay the market price, not your bid price, unless the two are the same, right? When the market price exceeds your bid price, you get 2 minutes to wrap up. And the market price, on average, is 85% lower than the on-demand price. Let's take a look at a specific example. So here's a screenshot from an R3 4XL. This was taken a few weeks ago. Under our on-demand purchasing option, this would cost $1.40, roughly $1.40 an hour. And if we take a look at the market price here, we can see at the time that this was taken in this availability zone, it was about 18 cents for the market price. And if we start thinking about, well, what are our bidding strategies to get the maximum value from the spot market, we can let's take a look at a couple different bidding strategies, right? Let's take a look at a 25% bid. So you bid 25% of the on-demand price, or 25% of the on-demand price, and which means you'll keep your instance in this case for almost 7 days. You'll get interrupted a couple times, but only for short periods of time. But you got 86% off, right? Basically paying 20 cents an hour, or 14% of the on-demand price. If we raise that bid and we say, all right, let's make it a 50% bid, we only got interrupted once, and in that whole time. If we set our bid to 75%, we didn't get interrupted at all, and we still saved a tremendous amount of money because we're only paying what the market price is, not our bid price for this whole time. So in this case, we ended up with an average discount of 85% at just 21 cents an hour, and essentially paying 15% of the on-demand price. So that's pretty cool. What else can we do to help with these spot pricing or bidding strategies? Well, one of the things we can do, let's say you have a job that you want to run for a longer period of time, but you don't need to run it for days. Spot blocks will allow you to specify a 2 to 6 hour block of time at 50% of the on-demand price. And you can, if you're doing this through automation, it's just a single additional parameter for the command line interface. So that's a good way to save some money, potentially, if you have a short 6 hour or less job. If you want to run longer than that, then we've got some other tools. So this is from AWS Labs, and there's a tool here called Get Spot Duration. And what it does is it helps you find capacity pools. A capacity pool is a combination of instance type and availability zone. Okay? And what the tool will show you is which of those capacity pools have the lowest price volatility over the past period of time. Okay? And we see an example here of the tool being run, and all of the values are 168. 168 means that the spot price hasn't been exceeded during this time. It's 168 hours by default. So all of those capacity pools for this instance, or those instance types, if you were running jobs there, you wouldn't get interrupted. Another tool that we offer that kind of does the same thing, but a little more visually, is a Spot Bid Advisor. The Spot Bid Advisor, you can see we've got a number of green blocks here up on the screen. Those green blocks are instances and availability zones, so that capacity pool once again, where you wouldn't, where your bid price would not have been outbid in the last week. Okay. So if you want to take this even further, we have a partner. I just discovered these guys as I was doing the research for this talk, called SpotInst. That's pretty cool. They specialize in running spot instances in production for you. And they handle the risk, and they take a percentage of the savings from the on-demand price as their compensation for doing this for you. So might be worth investigating. Okay, reserved instances. I talked about this briefly. Reserved instances are a way to give us a capacity commitment, and we'll give you a price break. The only thing I wanted to highlight here is that in the vast majority of cases, it's financially better to buy that RI today and don't wait instead of waiting, right? You don't need to wait for a new instance type or price. Well, maybe this week you might want to wait, because who knows what's going to be announced. But in most cases, you're going to be better off by buying now and getting those savings today. And if you need to change it, you can buy convertible RIs, or you can sell those RIs back on the RI marketplace. So, kind of in summary here, we've got a bunch of different ways to save money with EC2. Starting with on-demand for some of those transient workloads, maybe that benchmarking that I mentioned earlier. Going to scheduled reserved instances to save a little bit, going to standard reserved instances to save more, going to spot blocks for those jobs that are going to run for 6 hours or less, and then to save the most, going straight to spot, right? And you get to choose what's appropriate for your business, and I would argue that most businesses use a combination of these things. Okay, so let's talk about some specific architectural optimizations. I want to talk a little bit about augmented auto-scaling, offloading, licensing, and SaaS. Let's see, yes. So, auto-scaling, it's not just for instances, right? Here's a couple of tools that you can use to change the provision IOPS for DynamoDB on the fly, right? These are both open source tools. They're both on GitHub. But you can use these tools to change your DynamoDB provisioned IOPS or IOPS according to load or projected load on the fly. Really, it's about that value that we talked about at the beginning. Pay for what you need, right? So we've got dynamic DynamoDB, and then another tool called DynamoDB Lambda Autoscale. Jeff Barr has a post on this second one. If you're interested in those, you can go to their website or check out Jeff's post. And then, we started this talk by talking about dollars and cents. I really meant that in the terms of common sense. It should be pretty apparent by now that the more you can offload, the less infrastructure you need to maintain, scale, and pay for. And a couple of easy ways that you can do this are through caching, using CloudFront, and utilizing existing AWS services. So let's take a look at caching for a minute. So caching is a good way to save money. Here's an example, a very visual example, of DynamoDB before and after putting cache in front of it. Right? In this case, we saved 20,000 reads a second by using that cache. So cache frequently, it's a good way to save money. And potentially improve your performance. You can offload your traffic to S3. S3 can be used to host static websites. You can front that static content with CloudFront to increase your performance and lower your costs. And if you have dynamic content, you can do the same thing, front that with CloudFront, and that can reduce the load on your servers, meaning that you can run fewer servers or potentially smaller instance types, saving money. So that's our offloading model. One that may not be apparent is license flexibility. So with Microsoft workloads, you have the flexibility to bring your own licenses, BYOL. This allows you to pay the Amazon Linux price for Amazon EC2 instances instead of paying for license-included versions of those instances. And then taking a look at some SaaS-specific tactics. So when you're delivering a SaaS product, you're collecting a lot more data, you've probably got more infrastructure, and that gives you a greater ability to optimize across your infrastructure. Now, one of the things that may not be apparent here, though, is that you don't have to give the same infrastructure to all of your customers, right? You can allocate cache to your most demanding customers or most important customers. You can grant different instance types per client, maybe depending upon their customer tier, right? Or their demand or the time of day or how much they pay, et cetera, right? And all that can happen in the background. The customer might not even be aware of that. Well, one of the things that's important here is this concept of loose coupling. I like to say fungible architecture, right? Design with fungible architecture in mind so that you can replace things easily. And that is a way that you could tie in things like Lambda and serverless. And this is great for multi-tenant applications because the cost of those things scale along with the cost of your client base, right? So you're not having to invest ahead of time. You're only investing when you get a new client. If you want to know more about this, we've got a partner, solution architect, colleague of mine, Todd Golding, who has a couple of talks. Evidently, these have been popular because they've added a couple more sessions. ARC 301 and ARC 408, all about optimizing SaaS. And with that basic foundation, I want to invite Judd Kaiser up to talk about some real-world experience that he's had with Ansys and their journey to the cloud. Thanks, Judd.
Thanks, Elvis. Going the wrong way. Okay, first, I do not have a cool nickname. So I'll start by telling you a little bit about what it is that Ansys does. Ansys is an engineering software company. We allow our customers to build virtual prototypes to predict before they build products, including physics that involve structural mechanics, fluid mechanics, and electronics, and entire systems. They can predict how those systems will behave in the real world before they build them. And despite the fact that this talk is about cost optimization, like Elvis, I'll start by focusing on value. I mean, normally as talking about simulation, we'd be talking about the value of performing simulation, not the cost of it. And simulation's a lot more pervasive than you may realize. And chances are that every engineered product that you use in your life, your cell phone, your car, the aircraft engine in the plane that brought you here, were engineered, could have been engineered, or should have been engineered with Ansys simulation products. And for our customers, the cost of being wrong can be very high. In retrospect, a few $1,000s spent in AWS EC2 usage would have seen money well spent if it could have prevented, for example, a cell phone blowing up when it was charging. And so really it's about the value of being right. Now, okay, so why am I talking about simulation in the context of cloud? What trends are driving our customers to consider cloud computing? Simulation, quite recently, was the purview of experts. It was analysts did this, they had PhDs, they did it late in the design cycle, and it's about predicting before they, that last prototype before they built. Now today, it's becoming more pervasive. It's used commonly by designers earlier in the design cycle, so you're being used by more and more people. In the fairly immediate future, it's not hard to imagine, and actually we aren't imagining it, we're doing this, that even field engineers will be using simulation even though they're not aware of it. They might be out in the field responding to a service event that was predicted by simulation in the loop that was being fed inputs from sensors operating in the field for a device that was connected by the industrial Internet of Things. So they're going to be out there to fix a device that's predicted that it's going to fail. Now, all of this simulation, regardless of which of these guys is doing it, is computationally very resource intensive. Our simulation softwares are commonly being run in HPC environments to drive down the simulation times or to allow us to solve larger problems. They're solving them on routinely thousands of cores. Individual simulation runs, the data files are commonly tens or hundreds of gigabytes in size. And so that growth, both in the reach of simulation and the scale of simulation, has driven our customers to centralize their compute resources. More commonly now, these are in data centers, That's where all of the HPC cores are. It's where the storage is. Increasingly, even graphics services are being centralized in the data center. These data centers are complicated and expensive to build and maintain. And our customers are considering how they can migrate these simulation ecosystems from on-premise data centers into the cloud. And so now let's talk about what is the cloud-based simulation solution that we've delivered. Now, this is something that we developed in partnership with Ansys and several other software partners and released for the first time in May of last year. So this is still new. The paint is drying. Now, what we've delivered is a complete cloud-based simulation data center. And before I get into the details of cost optimization, sort of at the heart of that, what drove them to cloud was HPC. They wanted more cores. And so at the heart of the data center is an auto-scaling HPC cluster. And obviously there's a cost optimization right there to begin with, because auto-scaling by its very nature delivers cost savings by scaling to zero when not loaded, right? And then it delivers value by scaling up when it's needed. And even calling it an HPC cluster is an oversimplification. We don't have one solver with one specific type of needs. As Elvis said, you kind of have to match your compute needs to your product's demands for CPU power, RAM, and storage. And actually, our solvers, we have dozens of them, all behave differently. And so we can actually use different instance types optimized for that individual solver for the auto-scaling instances, the HPC. And to give you a sense of scale, one of our solvers, a CFD solver, we routinely run very large core counts. So here you're seeing good solver performance, good scalability up to a couple of thousand cores. So that means one run can be running over 100 fairly expensive instance types. And so the ability to optimize what instance type you use is in itself a cost optimization compared with on-premise, where they tend to provision one compute type that's used by all solvers, and you're making some compromise for some aspect of that solver. Okay, so that's just really the compute component. Well, we also have, I talked about the volume of the data involved. So we have storage that's involved, and there's cost optimization in choosing the right type of storage solution from AWS. We use SSD-backed EBS volumes for the work in progress data where performance is important, and for archive data, we're using lower cost S3. We expect cost optimization to continue. Over time, we'll get better with that, and we'll start to use, infrequent access S3 and Glacier for longer term storage. So more optimization coming. And we want to be able to work with the data in place. And that means after the compute is done, I have to pull up a graphics workstation so I can work interactively with the software with the data in place. And what we're replacing in the cloud now is what we used to buy for engineering workstations that sat on the desktop. They needed a GPU, they needed a certain amount of RAM, and they were provisioned based on the biggest problem you needed to solve in the next 3 years. And the GPU certainly sat idle on nights and weekends, and it was probably over-provisioned most of the time. In the cloud, we can use an instance that's right-sized for my need in the moment. And so all of this is just fundamentally, this is the cost optimization that's fundamental to cloud. Okay, so you get the sense that this is kind of it's a fairly complicated solution, it's a large-scale solution, and how has it evolved over these last 16 months? As I said, we provisioned the first release of this in May of last year. And over that period of time, we've gone through 4 major revisions of the architecture. We designed for what we thought was the use case, and we probably over-provisioned the system. And with each subsequent release, each subsequent iteration, we were able to optimize the underlying infrastructure by understanding what were the actual loads on the system and revisiting the requirements, right? So when we first built the system, we really put a heavy emphasis on redundancy and reliability and universal availability, and we probably over-provisioned it. And that had cost implications and actually performance implications. The other thing we realized is that customers aren't going to go all into cloud overnight. So we needed to be able to have a version that was lighter weight, use smaller instance types for them to start with, and then they could scale up from there. So in that 16-month period, and for reference, in that same time period, we built 1 physical data center in India. In that same 16-month time period, we've gone through 4 major revisions. We've tested it in 5 regions globally. We've undertaken a dozen customer pilot projects. And by a couple of specific metrics, the cost of the persistent infrastructure, the servers that are running all the time, those have gone down by 70% in that 16-month period. And by one measure of performance, the data transfer rate from work in progress to archive storage, that has gotten 18 times better in that same time period. And how do we do that? Just by continually right-sizing the infrastructure, as Elvis said. We figured out that certain instances were under-provisioned. We actually got some good economies of scale by consolidating services that were previously spread across multiple instances onto a single larger box. And we got better performance because that larger box had better data transfer rates across the network, right? So that service consolidation also delivered cost savings. Now, that's about the cost of running this solution. Now, this is not a SaaS solution. We're not selling the Ansys Cloud to our customers. We've simply engineered a solution using AWS architecture that allows them to have this virtual simulation data center. So what's the implication from a cost perspective for the customer? And what journey will they go through for cost optimization of using the system? Well, certainly they see the value of this elastic HPC capacity. That's what they were interested in. That's what brought them here. But what we've discovered is it's a whole new business model for the customer. That's an adjustment for them. It was an adjustment for us in-house. We're really used to, as engineers, what I call the buy it and live with it hardware model. What do you need? I bought it for you. Don't talk to me again for 3 years. Right? Cloud is use it, track it, and optimize. And our customers have to understand that that's going to be part of their journey. It's been part of our journey. And they will evolve to a model that will end up, they will use a mix of different instance types, mix of business models. Reserved instances for the infrastructure that runs all the time. On-demand instances for those periodic workloads. And Spot is particularly well suited to this auto-scaling HPC. And oh, by the way, that's the biggest cost component of this solution, those thousands of cores that we run for the compute. So the ability to take advantage of Spot delivers real cost savings. Now, so that's what our customers, that's the journey they will go through. Now, we are also a customer. We've engineered the system, but we use the system. What have we learned in the course of using it over the last 16 months? How do we manage the cost? Well, first we use multiple accounts. We got an account for the development team, account for test, account for production workloads, and that naturally segments things that you can see who's spending what on the detailed billing reports. We use instance tagging for the auto-scaling infrastructure so we can tell who used what. And we're making use of detailed billing reports. We are using one of those partner solutions, Cloudability, ourselves. We used it initially to help us optimize the reserved instance purchases. And in truth, we keep using it because it provides visibility. Automatic reporting that goes to the execs that need to see it, so know who's used what. And oh, by the way, make them accountable if they didn't use Spot when they should have, right? The journey is far from over. It's still day one, as they like to say at Amazon. And we expect these optimizations to continue. New instance types come online that drive down, that improve the price performance. You hear about price reductions. We'll be hearing more this week, I hope. That's all exciting stuff. New services are coming online that will simplify and lower the costs. It's going to continue to be fun. So with that, I will pass back to Elvis.
Awesome. Good job. Excellent. Thank you so much, Judd. It's really great to get some real-world perspectives there. So, kind of ending or starting back where Judd ended, right? This process of continual cost optimization, right? And we started this talk with the realization that we needed to do monitoring, right, and forecasting and alerting. But what if we can do that continuously, right? Not just point in time, not just do it quarterly, right? If we're getting value from doing it quarterly, why aren't we doing it daily, right? Let's provide that visibility. And ideally, this would be an automated process. So we want that continuous monitoring and forecasting. The other thing that we want to do is we want to actively manage our environment based on these measurements, right? Clean up your own mess, right? Give visibility, allow people to clean up after themselves, right? Once again, driving responsibility. And if they don't, then let's automate that the way Infor did, clean up for them. Let's architect for value, right? Create that fungible architecture, review your architecture when new services or technologies are announced. Look for examples of cost optimization in our case studies and at events like this, We've seen a couple of presentations that will allow you to do that. In researching the things for this talk, I found a couple of cool case studies that provided some cool cost optimizations. Do the right sizing, and remember that the optimum instance size may not be a bigger one or a smaller one, right? It may be in a different instance family, especially if you're using Spot and you're looking at those capacity units in different availability zones. Benchmark using your applications, or even better, maybe you move to using no instances, using serverless and Lambda and S3 web hosting. And then purchase wisely, right? Use the RI recommendations from our tools, from these partner tools, to drive your purchasing.